Good morning, folks. We're going to talk about area of basic shapes. This corresponds to your textbook section 11.1 and 11.2. In this particular, for this particular lesson today, some of this stuff is stuff that you've had for a long, long time, things that you have seen before. So it's kind of a review, but maybe there might be a couple of new problems. So I'm just going to remind you of some of the basic things that you've seen. Recall that the area of a rectangle, the perimeter of a rectangle is found by adding up all the sides. Remember that perimeter for any polygon is found by adding up all the sides. And area is found by multiplying the lengths of those sides together. Remember that also that perimeter means enclosing a space, kind of like a fence around a yard, or maybe a border. Maybe if you're putting a border around a garden, like a border of bricks around a garden. And then area is filling in a space. So remember that perimeter would be the distance around a figure or adding up all of the sides of a polygon to find the total sum of all the sides. Perimeter is measured in units, linear units, not square units. And then area, recall, means what does it take to fill a space, right? So area would be if you were filling a space. Area might be like something like painting a wall, or area could be creating tiling your floor, putting carpet down in the floor, or something like that. Maybe tiling the ceiling, that would be area. There are certain things, especially when you go to the hardware store, Home Depot, Lowe's, whatever, certain things are sold in square units for area, and certain things are sold in linear units. Fencing is probably something that would be sold in linear units, because fencing, you're concerned about being able to go all the way around a shape, whereas area, you're concerned about filling in a shape, right? All right, so base times height will give you the area of a rectangle. I know that frequently you are accustomed to seeing this as length times width, or 2L plus 2W for the perimeter. Those are the same. They do mean the same thing, but we're going to start using a lowercase b for the length of a base and a lowercase h for the height of a polygon. Notice that obviously for a rectangle you have 4 right angles, so the base and the height are perpendicular, and any two sides are always going to be perpendicular to each other. And remember that perimeter is measured in linear units, so you just say units, and area is measured in square units, so you would say units squared, or you could just say square units. Either one is fine. You're going to see both of those probably often enough. And then you remember your formula for a square. If you want to find the perimeter, you add up all the sides again, or since all the sides of a square are congruent, you can just multiply the side length times 4, and S represents the side length. And I didn't say that for a rectangle, that B is the base length, and H is the height. So I should include that. So for a square, the perimeter is adding up all the sides, or just multiplying by 4 since they're all the same, and area can be found by S squared, square units. Remember? All right. Let's talk about a parallelogram. That might be something that's new to you. Maybe, maybe not. Parallelogram, really, the formula is just like the area of a rectangle. Area of a parallelogram is just base times height. But the critical thing to remember is the height must be perpendicular to the base. The base can be any one of the sides, but the height has to be perpendicular to that. So let's take a look at some of these terms a little bit, but this is definitely a formula that you need to know. And I typically like to write an abbreviation or a symbol if I have one for whichever area I'm talking about. So if I'm talking about area of a parallelogram, I'll put a little parallelogram in the subscript for A, or if I'm talking about area of a square, I might put like an SQ for square because there's not a symbol for that. But for triangle, I'll use triangle. So just recall that the base of a parallelogram could be any one of its sides. Be careful a little bit because it doesn't extend beyond that. So here, the base is only from this piece to this piece. That would be the base. And in the picture on the left, the base is this particular side right here. So the base is any one of the sides. And remember that an altitude is the name of the segment that's perpendicular. to the line containing the base, but the height, which is what we're going to use the most, is the length of that altitude, and we're just going to call it the height. But what you need to be careful of is the height. Make sure that the height is always, always, always perpendicular to the base. If it's not perpendicular to the base, then it's not a height. So in a parallelogram, the difference in a parallelogram and a rectangle is the fact that the height is not going to be the length of the other side in a general parallelogram unless it is specifically a rectangle. Okay, so please make sure to remember that the height must always be perpendicular to the base. That's kind of critical, and that's true for pretty much every polygon we're going to talk about. The height might be something slightly different. We might call it slightly different, something slightly different in other figures, but for right now, the height has to be perpendicular to the base. So our formula for area of a triangle, if you want to think about where it might come from, think about the fact that if you had a rectangle, and you drew a diagonal in that rectangle, what did you create? You created two triangles, right? So you created a triangle over here, and we can shade it. And so how is the area of that triangle related to the area of the rectangle? Well, if you got two triangles that are congruent to each other, and you do, then the area of that triangle has to be half the area of the rectangle. So our formula for area of a triangle is 1/2 base times height. Remember that b is equal to the length of the base, which can be any side, and h is the height, which must be perpendicular to the base. The base can be any side length. If you don't like writing it as 1/2 base times height in that form, you can write it as b times h over 2. These mean the same thing. These really are the same formula exactly. They're just expressed in slightly different ways, but they really mean the exact same thing. So here's a couple pictures of triangles, and notice that in this case, with that b kind of being centered, that's the length of this entire side. And notice that you have the height drawn perpendicular to the base. So if you want to find that area, it's just base times height. And we are talking about the area of this whole entire shaded region to get the area of the triangle. But in the triangle on the right, be careful a little bit, and you might have to draw in this triangle. It might not be in the notes that you've already printed. We want to find the area of the triangle, and this is the area of the triangle that we want to find. Okay, so be very mindful of that a little bit. Remember that the base can be any one of the sides. It really doesn't have to be at what you might consider to be the bottom of the triangle, or the one that looks like it's on the bottom. But do be careful that you understand that the base is only from here to here. It does not include the extra dashed piece. All that means is that we are extending that side so that we can drop an altitude and find out the length of a height that is perpendicular to that base. So yes, we would need to know the height, but we don't care about what that extra piece is outside of that triangle. All we need to know is this side right here. So be very mindful that you're not having to go through a lot of extra work. If the height just has to be perpendicular to the line containing the base, even if it falls outside a triangle. Remember that an altitude can be inside a triangle, or it can be outside a triangle. It can even be a side of a triangle. If we talk about right triangle, then in this case, the base can be the bottom edge, and the height can be the leg. But in a right triangle, the legs, whichever two legs they are, the legs can always be the base and the height of your triangle. It really doesn't make any difference which one is which, but because they form a right angle, because one is perpendicular to the other, because they are perpendicular to each other, then you can always use the two legs. Now you might not have that, and you might have the hypotenuse, in which case you'd need a different height. So let's talk about some application a little bit. We want to find the area of the parallelogram in each of these examples, and sometimes you got to be mindful. Sometimes the figure is going to be shaded and sometimes it's not, but I want to find the area of the parallelogram, which is all of this space. And remember that any one of the sides in the formula for area of a parallelogram is base times height, and the formula for any one of the sides, the base can be any one of the sides of the parallelogram. But if I want to find the area, then I need the base that has a corresponding height. And by corresponding height, I mean something that is perpendicular to it. So when I'm looking at those three pieces of information, notice that I have 8 centimeters on the left and 24 centimeters at the bottom. I'm not going to use those numbers to find the area because the 8 is not perpendicular to the 24. So I've got to be mindful to use the height, which is perpendicular to the base. That's given as 6 centimeters. So we're going to have to use 6 as the height and 24 as the base. And so when we calculate the area of that parallelogram, we get 144 square centimeters or centimeters squared. That's the area of your parallelogram. So what does the 8 do for us? Well, not much besides help us find perimeter. If we want to find the perimeter, we can still add up all the sides. So we have 2 sides that measure 8 centimeters, and so we could do 2 times 8. And then again, remember that opposite sides of a parallelogram are congruent, so we could do 2 times 8 plus 2 times 24. So you get 16 plus 48, and then you would get 64 centimeters for the perimeter. Remember, perimeters, linear units, and area square units. Okay. One more time, let's take another look at a different picture, similar, because some students really have a hard time when that height is not drawn inside the parallelogram. So when we're looking and analyzing this parallelogram and we want to find the area of the parallelogram, which means we're looking for this area right here, shaded in yellow, and it's not always shaded, but it should be kind of solid, then what we want to consider is that any one of the sides can be the base, as long as the height is perpendicular to the base, because area of a parallelogram is base times height. So I look at this 3 inches right here, and I notice that that's a side, but I don't see anything that's perpendicular to it. So I'm not going to use that. Now, if you had a height that went like this, then you could use the 3 inches if you needed to. That you could use that. But in this case, I don't actually have that height, so I'm not going to use the 3 inches. Instead, I'm going to use whatever the 2.3 is perpendicular to. So what I notice is that 2.3 is perpendicular to the line that contains this base, right? And this base, opposite sides of a parallelogram are congruent, so that's 1.4. It's also perpendicular here as well, okay? So the base can be 1.4 times 2.3, and 1.4 times 2.3 is going to give you an area for this parallelogram of 3.22 square inches. Okay, and I'm not going to find the perimeter this time. Make sure that you read your directions when you're answering questions in homework or on a quiz. Sometimes the answers say exact values, sometimes they say approximate to the nearest tenth. Sometimes if it does not tell you to approximate, then you should not. So you would not answer 3 if it doesn't tell you to approximate. You would not answer 3.2 if it doesn't say round to the nearest tenth. It's just an exact value. It is a terminating decimal, so there's no reason for you to not be able to type in the exact answer. All right, now we're going to find the area of a triangle. Remember that the formula for area of a triangle is 1/2 base times height. Again, if you prefer, you can just do base times height divided by 2. You just want to make sure you can identify the base and the height correctly. Sometimes you have extra information in a picture that you don't necessarily need. I want to find the area of the triangle shaded here in yellow. Remember that the base can be the length of any one of the sides. Well, I have a 10 right here, so I'm going to use that as the base. What I'm looking for then is a height. Do I have something that is perpendicular to the line containing 10 feet? So I'm going to extend this side. Doesn't matter that this 4 is here, but I do see that I have a height perpendicular to the line that contains it, and that height is 6.4. So this extra 4 feet right here, that's just extraneous information. It's there sometimes to throw you off, to make you think you got to find something else. Maybe, perhaps, it would help you get the perimeter. Sure it would, because you could definitely do the Pythagorean theorem a couple of times and you could find the perimeter if you needed to. In this case, I don't want the perimeter, just want to find the area. So we're going to plug in 10 for the base length, and we're going to plug in 6.4 for the height, and then we're going to divide by 2. And of course, again, as much as I can, I try not to, but you can use your calculator if you wish. 2 goes into 6.4, 3.2 times. Think about it like 64 divided by 2. Just don't forget your decimal. And then remember that when you multiply anything by 10, it's just going to move your decimal to the right 1 unit. So this area is going to be 32 square feet. Don't forget your units. If you were asked to include units, you really need to incorporate them. Okay? Let's try some problems of a different type a little bit. Okay, so now we have parallelogram ABCD, and we want to know the length of segment DE to the nearest tenth. So first, we're going to find the area of parallelogram ABCD. That means that in order to find that area, we're going to need to know a base and a height that is perpendicular to a base. Well, here's the base, AB. That's the easiest base I see. That's a base. So let's call that base. And then here's the height DE that we're looking for that's perpendicular to it, but I don't know what that is. So that is a height, but I don't know what that height is. And that's really the ultimate question. So I'm not going to use that to find the area. So let's call this base 1 and height 1. That's the base and the height that go together. All right. Let's see if we can identify another base. Remember, a base can be any side of a parallelogram. So here's something else that could be a base. This could be a base. Let's call that base 2. Can we find a height that's perpendicular to that? Sure can. Notice that segment CF is an altitude that's perpendicular to the line that contains that base. So here is the height that corresponds to the base that is 13 inches. So the first thing we're going to do is find the area using the base of 13 inches and the height of 9 inches. And 13 times 9 is going to be 117 inches squared. And then we're going to use that to find the length of DE. So now for part 2, we've got the same formula for area of the parallelogram, and the area, that parallelogram is not changing. We're not changing the dimensions. So the area is the same no matter what base and what height I use. Now, though, I want to find the length of DE, and that's the height that corresponds to the base that is 9.4, or AB. So I'm going to say 9.4 times DE, which is what I'm looking for, right? 9.4 times DE. So I'm just going to do 117 divided by 9.4. And when I type that in, I do get a repeating decimal, excuse me, not a repeating decimal, but an irrational number. It is not ending and it's not repeating. So we're going to approximate this. And let's check and see if it says what to approximate to the nearest tenth. So DE is approximately 12.4 inches. And that's how you can find the length of one of the heights when you do not know, or one of the dimensions maybe potentially that corresponds to another one, and that's unknown. All right, let's try that one more time. We have a parallelogram. We have sides of 15 and 18 centimeters. And the height corresponding to a 15 centimeter base is 9 centimeters. What's the height corresponding to an 18 centimeter base? So let's figure out what we want to do. We definitely should draw a diagram of a parallelogram. I don't think this one's going to give me the opportunity to do a nice job. So I'm going to draw a parallelogram like this. And since the sides are 18 and 15, I'm going to label the 18 centimeter base over here and 15 here because this one looks like a little bit shorter. And the height that corresponds to the 15 centimeter base is 9 centimeters. Well, clearly this looks terrible. My picture is not drawn to scale. So let's label that as 9 centimeters. And we want to know what's the height corresponding to an 18 centimeter base. Doesn't matter to me whether you would draw that height outside your parallelogram or inside, but it'll just help a little bit. Let's identify all these. Let's call this base 1, and let's call this height 1 because that's perpendicular to the base that is 15. Now let's call this base 2, and let's call this height 2 because this corresponds to the base that's 18 centimeters. Got it? Okay, so what did we do? Again, the first thing we did was we found the area. It can be done slightly differently. If you want to just set the base in the area of one equal to the base in the area of the other, that works the same way. But we're going to go ahead and find this using the 15 centimeter base and the 9 centimeter base. And 15 times 9 is 135. And then we're going to figure out what the height is that corresponds to 18 centimeter base using 135 equals 18 times h sub 2. So we're going to divide by 18, divide by 18. And we get 7.5 for the length of the height. So height 2 is exactly 7.5 centimeters. And that would be the height that corresponds to the 18 centimeter base. And what we mean by corresponding, the one that goes with it, the one that is perpendicular to the 18 centimeter base is the one we're talking about. All right, let's try a couple of other problems. All right, what are we going to do when we have a bit of a weird shape, something that's made up of? We might call this a composite shape, a composite figure a little bit. So notice that in the figure right here, we have a square, right? There's a square down here and a triangle up here. So it looks to me like the best way, and when you have an irregular shape, you can try to split it up into smaller pieces and then just add the sum total together. So what we're going to do is we're going to take and find the area of the square, and we're going to add the area of the triangle. So remember that the formula for area of a square is s squared, and the area of a triangle is base times height divided by 2. So what's the side length of our square? That's given as 6 inches, so 6 squared plus, what's the base and the height of the triangle? Well, we see the height, that's 8. What's the base? Well, that came from the square. Remember that the base of the triangle is the same as one of the sides of the square, so that's also 6. So that's going to be 6 times 8 divided by 2. So we have 36 plus, again, easiest to just cancel and get 24. And that makes it a lot easier to say that your total area is equal to 60 square inches. Okay, that one's not too bad. They can get a little more complicated, but now let's suppose we take the base length of the square and the triangle and double each of those to 12, but the height remains the same. Okay, well, now it's going to be a little bit different. Let's try this. So now we're going to say, all right, if we're doubling the base length, then we're making that 12 instead of 6, right? And then we've got a triangle, and we want this to also have a base of 12, but that height is still going to remain 8. Looks to me like that height has to remain 8 here, but now we have 12 inches for the base, but this is still going to be 6. It did ask us not to change the height of either figure. So this is, remember that now we've created a rectangle, and opposite sides of a rectangle are congruent, so the base of the triangle is the same as the side opposite the rectangle. So now we're going to do area of a rectangle plus area of a triangle, which means we're going to do base times height plus base times height divided by 2. And for the rectangle, the base is 12 and the height is 6. And for the triangle, the base is 12 and the height is 8. So now we have 72, divided by 2. 72 plus 48. And now we're going to get 120 inches squared. So what happened when we doubled one single dimension? What happened to our area? So now think about what I'm asking you to do is compare these things. What happened to our area when we doubled one dimension? So when one dimension is doubled, what did that do to the entire area? The area is doubled. So what do you think would happen if you doubled both dimensions, right? Think about that. That's typically an ACT or standardized test prep type question, ACT or PSAT type question would be, what happens if you double each dimension, something like that. So maybe you should try what would happen if you didn't just double the base, but you also doubled the 6 and doubled the 8, and see what would happen to the area in that case, okay? So now we're going to find the area of an irregular shape one more time. What we're going to do is we're going to split this up a little bit. You can split it up how you want. There's definitely different ways. I'm going to split it up this way, I'm going to draw a segment here. All of these angles that you see are right angles in here. So I'm basically creating rectangles all over the place, okay? Or maybe a square, we'll see. This dimension is 9 and this one is 3. So there's clearly going to be a 3 right here. And if this is 3 and it's congruent and there's a 3 right there, then that means that if I opposite sides being congruent, if I take the 3 away from 9, this is 6, right? And this dimension is 3, and this is 3, and this is 3, and this is 3. So if opposite sides congruent, this is also 3, right? And this would be 3 as well. And now it looks like we have everything we need. So what I'm going to do is I'm going to say this is rectangle 1, rectangle 2, and rectangle 3. And I'm going to add the area of rectangle 1 plus the area of rectangle 2 plus the area of rectangle 3. So what I'm going to do is I'm going to do 9 times 3 plus, notice now that for rectangle 2, this dimension was 6 because it's a little bit shorter, 6 times 3 plus, and now this one is going to be 3 times 3. So we get 27 plus 18 plus 9, which is going to give you 54 centimeters squared for the total area. Okay, so as much as possible, try to break the figure up into 2 different shapes. And of course, it's a good idea to think about what's another way to separate that. Definitely there are other ways to separate that. You could even consider making it larger and then subtracting what's being taken away. So let's figure out what the area is for this picture right here. So it looks like I'm going to split this up into, looks like it might be easiest to split it up into a rectangle and a triangle. Because this would be 4, and if this is 4, that means this has to be 8, because if I subtract 4 from 12, because opposite sides of a rectangle are congruent, that would leave me with 8 for this dimension, right? So we're going to do area of a rectangle plus the area of a triangle. We're going to do base times height plus 1/2 base times height, right? The base and the height of the rectangle are 12 and 4. If you consider that you're looking at 4 on the left and 12 at the bottom. And then the base and the height of the triangle, remember what I said about a right triangle, is that the legs can always be the base and the height. So I'm going to do 8 times 4 divided by 2. And now I'm going to cancel this and make that a 4. And we're going to get 48 plus 16, and that's going to give us 64 square feet for the area of the composite figure. Got it? Last thing we're going to do is talk about what happens if you graph in the coordinate plane and when you want to figure out what the area of something might be in the coordinate plane. So it's just a refresher about plotting points, drawing a shape. We're going to plot point E at -4, +3, 1, 2, 3, 4 on the x-axis to -4 and up 3. This is point E in quadrant 2. F is at 0, 3, so we're going to go 0 left or right. We're going to go 1, 2, 3 up. Here's point F. G has coordinates 1, -2, so I'm going to go 1 to the right and down 2 to point G right here. And H has coordinates -3, -2, so I'm going to go 1, 2, 3 to the left on the x-axis and 2 down. And this is point H right here. So then I'm going to connect these with segments. Here's EH, here's EF, whoops, FG, and HG. And then what I'm going to do is think about, well, how do I find the area of a parallelogram? Area of a parallelogram is base times height. Remember that the height must be perpendicular to the base, right? That's always critical, something to keep in mind. So I'm going to actually draw in a height, and we're going to make it dashed and red because that's going to be inconsistent. So I'm going to draw it like right here. Okay, and that'll be perpendicular. And a base can be any one of the sides. So I'm going to use HG as the side, and I'm just going to count spaces. So 1, 2, 3, 4 units from H to G, and this base is 4 units long. So I'm going to multiply 4 for the base, and now I'm going to count squares for the height. 1, 2, 3, 4, 5 is the height, and your area for your parallelogram is 20 square units. In general, if you're not given a unit of measurement, then you would write units squared or square units. And that's the end of just area and perimeter of some basic shapes. Got it? All right, have a great day.